For C, we have to divide the interest rate by the number of compound. And for the exponent, we have to multiply the number of compound by the time. So let's identify the different variables. P is the initial deposit, 7,000. R is the annual percentage rate. So we will write it as a percent, the decimal, 0.05. N is the number of compound. Compounded monthly means there are 12 compounds a year. So the number of compound is 12. So 0.05 is the interest rate per year. The number of compound per year is 12. So it's compounded 12 times, monthly compound. It's going to be 12 a year. 12 a year. T is the number of years. So we have the money was invested for 12 years. So now all we have to do is substitute, use our calculators, and get our answer. 7,000 times, open parenthesis, 1 plus the interest rate is 0.05. Number of compound is 12. And now the exponent will be n, 12, times t, the number of years, which is 12. $7,000 times 1.004. 12 times 12 is 144. Now, our answer is 12,738.94. The next one, we can use the same formula, just have to be careful with the number of compound. P is the initial deposit, and the initial deposit is 12,000. R is the annual interest rate, and it's as a decimal, it's 0.085. Now, N is the number of compounds, and the account is the investment is compounded quarterly, so we have 4 compounds a year, 4 times a year. It's 4 times a year. Okay. Now, the time is given. Time is 2 years. Going back to the formula, we will just substitute each letter for its value. 12,000 times 1 plus 0.085 14.85 divided by 4, which is the number of compound. Let's take care of the exponent. It's going to be number of compound 4 multiplied by the time, which is 2 years. So A is equal to 12,000 times 1 plus, well, as a decimal you get 0.2125, and then 2 times 4, 2 times 4 is, and we get this approximation for the ending balance, 14,198.35. And that's it for this question.